Our next update is creating custom decorators with logging errors on file. First, we need to import the necessary modules for our implementation. Logging, that's Python built-in logging system. It allows us to record error messages, warnings, and debugging information. This is useful for tracking application behavior and diagnostic issues. Wraps from functions, that's used for function decorators. It is primarily used when creating decorators to preserve metadata such as the function name and docstring, and up exception from error handlings, the custom exception class we previously created. I will manually create the error log file. Come back to decorators and paste the logging code. This code snippet ensures that errors are logged to a file inside the app directory. First line creates the empty error log file if it doesn't exist, but we created the error log file manually. The A tag ensures the file is not overwritten if it already exists, and the close immediately closes the file to avoid unnecessary open file handlers. Then we are configuring the logging system. File name is the directory where logs are written. Level shows the level error and above. And with the format, we are defining our log format, timestamp, log level, and the actual message. Next line creates a logger instance for the current module. Why all this is useful? Ensures all errors are recorded, keeps logs separate from the console output, automates log creation, and enables structured logging. Next main step is to discuss our handle exceptions function. The goal of this function is to create a global decorator for handling exceptions in FastAPI routes. It ensures that all exceptions are caught and logged instead of crashing the application. Errors are formatted properly and stored in the log file, and the debugging is easier. Inside the function we are using decorator factory, meaning it takes the argument and returns a decorator. This line defines the actual decorator that wraps around any function. The try block runs the original function, and if an exception occurs, the except block handles it. Then, in the except, we are formatting the error message, name of the function, status code, and the actual error message. And logger error logs the message and also logs the full traceback, which helps in debugging. After that, we are printing the formatted error in the terminal. That helps developers immediately see issues while testing locally. And then we are raising a custom exception that returns a JSON response. The wrapper function is returned inside the decorator, and the decorator function is returned inside the handle exception function. Next function that we will discuss is how to handle exceptions. The goal of the function is to automatically apply exceptions handling and logging to all methods of a class. This makes error handling more efficient and consistent across the entire class, such as controllers, service, or repository. We have again a decorator factory that allows to specify a default HTTP status code. Then we have an inner function that acts as the actual decorator for a class. Looping through class attributes, we are retrieving all attributes and methods of the class as key value pairs, And with callable, we are ensuring we only process methods, ignoring attributes. Also, we are skipping methods like init or str or others like that. On the next line, we are replacing the original method with a decorated version. First, handle exceptions return a decorator. Then, that decorator wraps around the method. This means all methods get automatic exception handlings. And after modification, we return the updated class. Next step is to use these decorators. Actually, this is the import. We have to import them first. And then we have to use them. In the proper places. And here there are different types of strategies. For example, we can use this decorator also in the repositories. That ensures any errors caught are logged immediately. Otherwise, the errors will bubble up and caught at the controller level. If you have errors in the repositories or services or controllers, they will be caught. The next thing I want to do is improve the folder and file structure. I'm not going to make many changes as this is not a production ready application, but rather an educational tutorial. Also, I apologize if the screen changes. This happened because I continue recording the tutorial on a different day, which is why you may notice a screen change in the middle of presentation. Let's create our new folder called modules and move modules.py file there. And next thing we can do is to create a folder called schemas and move our schemas.py there. But I want to make reference changes with of course, yes, okay. And repositories folder, repositories with repositories.py inside next services and services.py. Where did it go? I cannot see it. Repositories, modules, repositories, services. And for decorators handlers, we will need probably helper, and decorators with our handlers inside the helper. That's a little bit better as an architecture. And let's test it out, see the results. And we don't have any changes, probably because every time we move the file to the new directory and the paths are automatically updated on top. And that's why everything works perfectly fine. Our next important update is in services.py, where we have a function that creates a vector from data, generate vector. However, at the moment it is implemented at the basic level. We need to improve this by using an embedding model, and in our case we have chosen to use SentenceTransformers. Why? Well, in our next video we will discuss embedding models, covering different types, their benefits, trade-offs, and more. But for now, let's focus on completing the application. First, we need to turn off our application so we can install the new embedding model. Next, we need to run this command in the terminal, pip install SentenceTransformers. We are in our virtual environment. And we are installing the package, the embedding model. In my case, I have to wait a little bit until everything is installed, so I can use it later. Still waiting. I think it's almost complete, but yeah, we are still waiting. And waiting and waiting. And we are done. We are ready. We have to make a few modifications in this file. First, we have to import SentenceTransformer, a class used for loading transformer-based models for text embeddings. This allows us to use pre-trained models for generating text embeddings. Then we are loading the pre-trained MPNet model, which is designed for semantic similarity tasks. And we have to make modifications in our function. Instead of using this basic model, we will use our new model. Instead of using this conversion, actually, we will use our new model. Let's explain what is happening. We are using MPNet model to generate 768 dimensional vector for the input description. Then we are using NumPy to convert the vector into a list of lots values. That ensures the vector is in compact format, and we are returning. And now we are going to have some issues because of that, because our previous version actually were using 300 dimensional vector, and this one is using 768 dimensional vector. And based on that, I'm guessing the Qdrant, our database, is going to have issues. But to see that, we need to run our application. After running the application, everything works. Then going to uploads, post, we have the JSON data, send. and we have other types of issues. So let's see. Yeah, probably that's actually the correct path. And now we have that everything works fine. Let's actually test with a test to be sure that right now the application works fine. So let's make our post on the, and actually it worked. It was converted, generated vector length. Well, perfect then. Everything works fine. So at the moment we have working application. We are running the server. Then we are passing data with the routes. We are catching that data, passing to the services. At the services we are converting the data into a vector, and then we are saving that vector in our Qdrant database. And pretty much the process is working fine. Here we can see the conversion, and then we have the vector saved.